Okay, let's just jump right into this. Have you ever asked an AI to solve a really complex, multi-step problem and then caught yourself wondering, wait, how did it actually get to that answer? And more importantly, can I actually trust it? Well, in today's explainer, we are diving into a massive heavyweight showdown. We're looking at the intense battle between open and closed AI models, and we're tackling a huge developer dilemma, the absolute nightmare of black box troubleshooting. So here is our fight card for today. First up, the setup. Then, open versus closed traces, measuring efficiency, optimization limits, synthetic versus authentic, and finally, building trust. Let's get to it. Round 1, this setup. Now, to really push these models to their limits, we're not just asking them to draft a simple email. No, we're throwing them into a really complex button press constraint test. It's essentially a logic puzzle with super strict rules about floors, jump logic, energy balances, the whole shebang. And the goal is simple: find a valid solution in the absolute shortest number of steps. So, in the red corner, representing the open model, we've got DeepSeek version 4 Flash. And in the blue corner, the closed model, Gemini 3.1 Flashlight Preview.
But before we actually look at who won, we kind of need to understand how they fight, right? Section 2, open versus closed traces.
To really grasp this showdown, you absolutely need to understand what a reasoning trace is. Basically, it's the visible, step-by-step logic an AI uses when it processes a prompt, explores solutions, and formulates its answer. Think of it like showing your work in math class. DeepSeek is an open model, so it provides this authentically. You can literally read its mind as it works, which is incredibly cool. Gemini, on the other hand, is proprietary. Under standard settings, it completely hides this whole process inside a black box. You hand it a prompt, and it just magically spits out an answer. Okay, so let's see what happens when these two different philosophies hit the real world. Section 3, measuring efficiency. Right out of the gate, DeepSeek lands a super efficient 10-step solution. And because of that open reasoning trace we just talked about, we get to watch it happen live. We see it invoke the right constraints, navigate the logic, and deliver a totally solid verified answer. Boom, 10 button presses. Now contrast that immediately with Gemini. Gemini comes out swinging with a 14-step solution. But wait, during its live verification run, it realizes, oops, its own previous solution was actually invalid. And since it's operating entirely in the dark, it tries to live correct itself, bumping up to 15 steps, and then awkwardly stumbling all the way to a really clunky 18 steps. So 10 steps for DeepSeek, 18 for Gemini. I mean, round 1 clearly goes to DeepSeek for sure.
Let's move on to Section 4, optimization limits.
You know as well as I do that developers don't just want a first draft. We want the absolute best possible efficiency. So we prompted both models to try different strategies and find the shortest possible path. With DeepSeek, the visual clarity is just incredible here. We literally watch it extending its search space, testing alternate decision patterns, basically saying, let's try this path. No, wait, let's try this one, before finally exploiting the best solution. It's pure, authentic, mathematical logic laid bare for the developer. And the final scoreboard really tells the story here. DeepSeek takes its already awesome 10-step run and mathematically refines it down to an insanely tight 8 steps. Just brilliant. Meanwhile, Gemini takes that clunky 18-step run and only manages to wrestle it down to 10. DeepSeek absolutely dominates this optimization round. But you might be wondering, what if we force Gemini's hand? What if we crank its syncing settings to high? Well, that brings us to Section 5, synthetic versus authentic. When we actually force Gemini to show us a trace, it outputs phrases exactly like this: finalizing the strategy, mapping the early floors, revising the jump logic. I mean, come on, let's be real here. This reads way more like a corporate marketing brochure or maybe a sci-fi movie script than it does authentic, rigorous mathematical logic. So it really begs the question, are we looking at actual reasoning here, or is this just an artificial, synthetic summary that was generated after the fact? Well, the data heavily points to the latter. It basically acts like a summarized pacifier to keep the user happy, rather than giving us a genuine look under the hood. And honestly, the performance data totally backs that up. While Gemini was busy generating that flowery synthetic trace with its maxed out syncing settings, its actual first output for the problem was a catastrophic 20 steps. 20 steps was the absolute maximum allowable limit for this test, so completely failed the efficiency benchmark while trying to narrate its own fake thought process. Just wild. We actually gave it one more chance to optimize that 20-step disaster, and it did give us 12 steps, but
There is a massive catch here. The solution was completely incorrect. It didn't even solve the puzzle. By forcing a closed model to act like an open one, we didn't get transparency. We got a synthetic trace and a totally broken answer.
So, what does this actually mean for real-world enterprise development? Section 6, Building Trust. Look, an 8-step versus an 18-step sequence is a massive gap in computing overhead. But frankly, the reason I personally prefer DeepSeek's OpenTrace is simply because it builds trust. When you can actually see the logic, that transparency prevents the absolute nightmare of blind troubleshooting. If the model makes a mistake, you can see exactly where it took a wrong turn. Open logic is what enables highly complicated scientific and enterprise tasks. Conversely, those synthetic summaries, they just mask the model's flaws. True efficiency absolutely requires visible verification. Which leaves us with this final, absolutely critical thought. When you are building your next enterprise application, or you're running your next complex optimization task, can you really afford to trust a black box? Or do you demand the transparency, the efficiency, and the verifiable logic of an open reasoning trace? I think the data we've explored today makes a pretty compelling case for keeping things out in the open. Thank you so much for joining me for this explainer. I really hope it brought some clarity to your day, and I'll see you on the next one.